All right, so we just talked about experimental probability, and experimental probability, again, is probability when you have an actual experiment that you're conducting. So when you are doing like flipping a coin or spinning a spinner. So when we talk about experimental probability, remind me what sample space is?
Like the outcome?
The possible outcomes. So a sample space should just be a list, right, of all the possible outcomes. And then experimental probability is going to be based on like a frequency table or some description of the experiment that is done. But experimental probability is if you're actually doing something or conducting an experiment. Right now we're going to talk about theoretical probability. And what does it mean to be theoretical?
Like possibly like a theory, like kind of like a theorem.
Yeah, it's not like 100%. It's a theory, okay? What do you mean by like a theorem?
Like Pythagorean theorem.
Okay, but what is a theorem?
A theory.
Okay, kind of, yeah, I mean, sort of.
Like it tells you so much,
Okay.
but then you have to figure out the rest.
Okay, so there's a little bit, they're telling you a little bit, but you might have to figure out the rest. So theoretical probability, theory like just means you're thinking about it, right? So there's not an actual experiment that's happening. You're just thinking about what the likelihood is. So when I say what's the theoretical probability of flipping heads when I flip a coin, what would I say? 50-50, because theoretically, when I flip a coin, half the time I should get what? Heads, and then half the time I should get tails, right? So theoretical probability is I'm not actually physically flipping a coin. I'm just thinking about what are my options, how many of them are heads, and then what's the likelihood that I would get it, okay? So experimental probability has to be based on something like this. In number 10, an experiment here, the experiment being the guy checking the tires. How many times did he find defective ones? 6. So he actually checked how many tires? 80. So he ran 80 experiments and 6 times they were defective. All right? Theoretical probability would be based on not an actual experiment, but something where you don't necessarily know, you're not actually conducting the experiment, but you're guessing theoretically what the probability would be. So, yeah.
How would you figure out if it's like a tire?
The way that they test it usually is they fill up like a bucket of water, and it's like soapy water, and if you throw a tire into it, if it's got like a hole in it, it'll bubble. Yeah, it makes bubbles from the hole. Does that make sense? So I would assume that's what they're talking about, because I don't know how else. I mean, I'm sure tires can be defective other ways, but my assumption would be that there's like a hole in the tire. But that's how they check if you have, like if you go to a tire shop, you say like, oh, I think I'm getting a flat. They spray like soapy water on it, and if it bubbles, then there's a hole. That's all I know about that. You guys always ask me questions about things that I don't know anything about, and then I just make up the answers. But I know that's true. Okay, so what's the difference between these two spinners?
The blue is bigger.
The blue is bigger where?
On
the right one? So it doesn't say not likely, it says what? Not equally likely. So what does that mean? Not equally likely.
It's not as equal.
It's not as equal as opposed to the first one. What's happening in the first one?
It's like usually
All the colors are exactly the same amount. So in this one, you can say, what is the experimental probability that if I spun the spinner, that I would get blue? 25%. Why? Because there's 4 and they're equal spaces, right? So the experimental probability here, the theoretical probability here for blue would be 1 out of 4. And if you want to express that as a percent, you can. Typically, it's expressed as a fraction just because it's like you don't have to do any type of conversion. You don't have to know any percents. You're just writing it. So 1 out of 4. Is it still 1 out of 4 in this one?
No.
Why?
It's like so much bigger than that.
Because it's bigger. So even though there's 4 sections, because there still are 4 sections, right? But what's wrong with those sections? They're not even. So how could you figure out what the likelihood of spinning blue is in that one? Why is it 50? Okay, so this is 50% of the circle, so it takes up half of it. So we would say the likelihood of spinning blue is 1 out of 2, because half of the circle is blue. How would you figure out the red? How would you figure out the red? Why?
Because those two equal 50.
Okay, so if I took this and I split it into all red size shapes, there's how many of them? 4, so it'd be 1 out of 4. How would you do the green and the yellow.
1 out of 6.
Not 6.
8.
8. Why 8? Because if you split the circle up into green and yellow sized pieces, how many would there be? There would be 8. All right, because it's like half of the red. So green or yellow are the same, and that would be 1 out of 8. So those are not the same probabilities because the slices of pie are not the same size. Okay, so again, theoretical probability is just asking yourself, what's the likelihood, before I do anything, what's the likelihood that I will spin blue? Now, if I actually start spinning, is that theoretical anymore, or is that experimental now? Experimental. As soon as you start doing something, it's an experimental probability. Before you do anything and you're just like sitting thinking, like your little calculator man with the thought bubble, right? You're just thinking about what the probability would be. That's when it's theoretical probability. So again, theoretical probability is just thinking about it. Okay, so if I'm talking about theoretical probability here of rolling a number cube or a die, all right? What's the theoretical probability of rolling a 3? Why 1 out of 6?
Because there's 6 sides.
There's 6 sides on a dice. How many on a die? How many of them are 3? 1. So 1 out of 6. All right? What is the theoretical probability of rolling an even number? 3 out of 6. Why?
So there's 3 even numbers.
Good. Which reduces to 1/2. Now, does that mean that if I roll a dice 20 times, 10 times, I'm going to get evens? No, because experimental probability isn't perfect, right? Now, what probability means is that the more you conduct the experiment, the closer and closer it will get to 1/2. So experimental probability is not always going to be perfect, but the more experiments you do, it should tend towards the theoretical probability. Okay, so that means like if I roll, the odds of rolling a 3 are, I'm sorry, the probability of rolling a 3 is 1 in 6. If I roll a dice 6 times and I don't get a 3, does that mean the probability of that is wrong? No, it just means that theoretically that's what it should be. But like you guys said before, a theory, a theorem, when you're talking theory, is it always 100% right? No, it's just the likelihood that it should be right. Yes?
And I also feel like casinos, they use probability a lot.
Say that again?
Casinos.
Yes. Tell me more about that. Casinos use probability all the time. What? How?
So like when you play like a dice game or something.
Yeah. When you're over 18 or 21 and you're legally allowed to go to a casino, right? That's what you meant to say? Okay.
What?
So imagine you are over 18 and allowed to go to a casino. Okay, and you're playing a dice game.
And like they don't want you to win all the time, so they want the probability of you winning to be unlikely.
Yeah, why don't they want you to win?
Because then
Household wins.
Okay, why? You guys know a lot about casinos. This is making me nervous. Why do casinos not want you to win?
Because you get tricked.
Yeah, they want to win because they want to keep the money, right? So the likelihood of winning those dice games is pretty low, right? But, so explain to me then, why do people play them?
Because they'll
It's
be,
addicting.
like sometimes my
Well, okay, regardless of like Gamblers Anonymous, like yes, it is addictive, I agree with you, but like,
mom, when she gambles,
Uh-huh.
it's like really, really close.
Uh-huh.
And she's like, okay, maybe if I keep going,
yeah,
I'll get it. And
okay,
it's like, it
so
makes-
because if you do win, what happens?
You
You get a lot of, it's like the whole risk reward thing, right? The higher the risk, the greater the reward, which is not always true, but like in theory, higher the risk, the greater the reward, right? So even if it's really unlikely, have you guys all seen roulette? Like you throw the little ball, it spins around, and then they're red and black, okay? So the odds of, or the likelihood that you're gonna win that is not very high, right? You put money on like black 12 or whatever it is, or you can bet on, like if I pick black 12, I'm betting that it will land where? In one specific spot, right? But you can also bet on just black. Is that a safer bet? Yes? Why?
There's more chances.
Because there's way more chances. But what does that mean for payoffs?
Less money.
There's way less money in it, right? Because the casino knows that the likelihood that you'll get it if you pick black is a lot. It's not quite 50 because there's the 2 little green spots, but close, right? So the likelihood that you'll get it is higher. So they're going to say, because the casino wants to win, they're not going to pay out very much for that bet, right? Good. What?
Money's money.
Yeah.
Oh,
You're still winning. It's good. Yeah, right? Money is money. That's true. But overall, over the course of the time that you're in a casino, their likelihood is that you're going to spend more than you. Like, more people go to a casino and walk away losing money than win money. And the casino has to, that's what they hope for, right? Because they want to win money.
Oh, when I was little, my grandpa,
Uh-huh.
he bought me like a $500 machine. It was like a little small.
Like a little slot machine?
Yeah, it was funny. Well,
Seems like an
it would
interesting gift for a
it would
child,
make like
but
a really loud noise
Uh-huh.
whenever you won.
I bet your parents loved it.
I don't know. No, it was just
Probably
really-
no.
It was just like little coins.
Uh-huh.
They gave you like 200.
That's cool though. So my mom goes to casinos sometimes, but she's responsible about it. Like, she'll say, this is what you should do. If you're ever going to go to a casino, here's my PSA. Say, I'm not going to spend more than $20 or whatever it is. And once you lose your 20, you're done, you go home. So, but my mom has a friend and she was going and playing roulette, and every time she was like, I'm winning every time. She would bet on red and on black. And so she was thinking every time she was winning. But what was really happening with her?
Spending a lot more.
She was winning, but she was also losing the same amount of money. So really, was she winning? She won nothing. And then, in fact, over the long haul, she's going to lose because every once in a while it'll hit the little green spot. So my mom was like, all right, you keep doing you. Because she didn't lose any money, really. But it was like she thought she was winning because every time she'd be like, oh, I got it. But it was like, that's not really winning. Okay. So boring, though. You just like...
You take all sponsored
Oh, it looks so
yeah.
boring.
And I was like, the coins, and then like I had the key, so whenever I was running out of coins, I would open it and take
You're like in charge of the casino and you're playing at it? Okay. All right, that was a good tangent about casinos. All right, so experimental probability versus theoretical probability. So in experimental probability, if we're talking about heads and tails, experimental probability, if you flip the coins 10 times, if you get heads 3 times, how many times did you get tails? How do you know it's 7, besides that it says it in the chart? 7 plus 3 equals 10. So together they have to add up to what? 10 out of 10, which reduces to what? 1. In theoretical probability, what are the odds of getting heads? 1 out of 2, and of getting tails, which still adds up to 1. So probability, theoretical and experimental, should always add up to 1 when you put together the likely option and its opposite. Okay, so we call that the complement. And the complement just means the opposite of whatever you're hoping for. Okay, so the probability of an event happening and the probability of its complement happening should always add up to 1 or 100%. So basically what that means is, let's say I tell you there's a 30% chance of rain today. That means there's a 30% chance of rain, but it also means what? 70% chance of it not raining. Where did you get 70 from? It has to add up to 100, right? So if the likelihood is that it'll rain 30%, then the likelihood it won't rain is 70. So every time you get an experimental or a theoretical probability, you're actually also getting the opposite. You're getting another one. Okay, so let me give you one more example. The probability of you getting a B on the final is 4 out of 8. No, 4 out of 10. The probability of you getting a B on the final is 4 out of 10. So what would be the complement to that? 6 out of 10 means there's 6 out of 10 chances that you will what? Not get a B. And it's not that you'll get an A, or that you'll get a C, or that you'll get a D, or that you'll get an F. It's just not B. It's just the opposite. So whatever the probability is, the complement is just not that. So like the opposite of raining is what? No, it's not sunny. The opposite of rain is not raining. Okay? Because there's a lot of options in not raining. Like it could be sunny, or it could be just cloudy, or it could just be it could be dark, you can't tell what it is. Okay? What's the opposite of sitting? It's not sitting.
Why? Why isn't it standing?
Because I could be lying down.
She could be planking.
I could be planking. I could be standing on one foot. So the opposite of sitting is not sitting. All right? Now that might not be true in English class, okay? Opposites, you might use different things. But here, when we're talking about likelihoods of opportunities of experimental and theoretical probability, the complement just means not that thing. Okay? So the opposite of thirsty, or the opposite of hungry is not hungry. It's not full, it's not hungry. Okay? All right. The weather forecaster predicts a 20% chance of snow. What's the probability of not snow? 80%. Good. Because it has to add up to what? Good. Okay, go do these 8. Okay, so the other way that we can talk about probability and likelihood is in terms of odds. And the odds are a little bit different than probability that we've talked about before. So the odds don't compare something to a total. They compare the odds of it happening to the odds of it not happening. So the ratio for odds, we write it as a ratio. So it looks like this. It would be like 1 to 2. All right? And the odds are not out of a total. They're out of the way it can happen compared to the way it cannot happen. Yes, the odds are like all the iterations. So, for instance, if I'm looking at this and I'm saying, let's say we have a spinner. Okay, what are the odds it will land in red? No. The probability is 1/4. So the probability is 1 out of 4, but the odds are 1 to 3. Why? It's a ratio, but how come it's 3 and not 4?
Oh, because there's 3 whites.
There's 3 whites. So again, reds are the odds that it will happen is red. So in favor of it happening would be 1. And then against it happening would be 3. So then how would you figure out your total? Add them together. So for odds, you would add it together. So 1 out of 3, 1 plus 3 gives you 4. That should add up to 4 because how many options are there? 4. Good. Okay, so rolling a dice, what are the odds versus the probability? What are the odds I will roll a 2? 1 to 5. Why?
Oh, because there's 6.
There's 6. So one of them is a 2. 5 of them are not 2s. All right, what's the probability though? 1 out of 6. So again, somebody describe to me what's the difference between odds and probability?
The odds are like compared to like what can happen and what cannot happen.
What can happen versus what cannot happen. Good. And then the probability is what you want to happen over the total. So it should be over the total. All right. So odds should add up to what? Whatever your total was in probability. Okay. So you can talk about the probability and the odds of the same exact event happening. All right. So let's say we have. Give me a word. Any word.
Potato.
What?
Tomato.
Potato. Did you both say potato?
I said tomato.
Oh, weird. All right, potato. Okay, I spelled that right. All right, what is the probability if I randomly choose a letter that I'm going to pick an O?
2 out of 6.
2 out of 6, which reduces to what? 1 over 3. So that's the probability. What are the odds that I will choose an O?
1 to 5. Wait, what? 2 out of 4.
2 to 4. Why?
There's 2 O's.
There's 2 O's and 4 not O's, right? There's 2 O's and 4 not O's. So again, odds is what you want to happen versus not happening. And probability is what you want to happen over the total. So the difference between probability and odds is that odds is not going to be out of the total, it's going to be out of the complement, so the opposites. Remember how we said the opposite is just like if it's raining, not raining? All right, so whereas you would say the probability of it raining is 30 out of 100, the odds of it raining would then be 30 to what? 70. Good. Why?
Because 70 plus 30 is 100.
Good. 70 plus 30 is 100. So the odds should add up to what? 100. Okay, because if this was 30 out of 100 for our probability, then these two should add up to 100. And odds will always be written as a ratio like this. All right, so with the colon in the middle. And you say it as 30 to 70. Okay, so the probability of choosing a red card from a standard deck of playing cards is 50%. What are the odds of choosing a red card? What are the odds of choosing a red card? Why? How many choices are there?
There's only two.
There's only two, red or black, right? Or whatever the other color is. So red or not red, because remember the opposite is not black or blue or whatever the other colors are. It's just not red. So if one of them, if 50% of them are red, how many are not red? 50%. So you could say 50 out of 100 is your probability. So then your odds would be 50 to 50, which reduces to 1 to 1. All right, so the ratio would be 1 to 1. Okay, the odds against choosing a green marble from a bag are 5 to 3. So the odds against are 5 to 3. That means which one of these is green and which one is not green?
5 is not green.
5 is not green. Why?
This is all green.
It's odds against, so that means not green. So then this means green. So then what's the probability that I would choose green? 3 out of 8. Why 8? Because you add them together. Because probability should be over the total, whereas odds is in favor, not in favor. Okay? All right, go try some of those. Go do these. Some of them are odds, some of them are, they're actually all odds. They all have 3 parts.